Lesson 13.4 on page 527 is called Measures of Variability. Our essential question: how can you summarize a data set by using range, interquartile range, and then absolute deviation? Okay, so a measure of variability is a single value used to describe how to spread out a set of used to describe how spread out a set of data values are. The mean absolute deviation is a measure of variability. All right. In gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation of the data set? So he jumped 54, 58, 56, 59, 60, and 55 inches. Okay, so find the mean absolute deviation. So we're going to start by adding all of this up and dividing by 1, 2, 3, 4, 5, 6. Okay, so 58, 56, 59, 60, and 55. All right, and when we add all of that up, we get 342 divided by 6. That would be, what, 5? 30, 42 would be 7. All right, so that's 57. Okay. The mean of the data set is 57 inches. So we found the mean right there, the average. Okay, now we're going to find the distance of each data value from the mean. How far was it from the mean? All right, so 54 is 3 inches less than the mean. This is the mean. So this is the same data set up here in this column. 54, 58, 56, 59, 60, and 55. And we found the mean, so we're going to find out how far each of these pieces of data are from the mean that we discovered. Okay, 58 is 1 away from 57. 56 is 1 away from 57. 59 is 2. 60 is 3. 55 is 2. And if we add all this up, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, so the distance between the data value and the mean, after we've added all that up, is 12. That's 6 pieces of data. 1, 2, 3, 4, 5, 6. So 12 divided by 6 gives us... we found the mean of the distances. So the mean absolute deviation, that's what we just found. The deviation being how far is it from the mean. So he's generally within 2 inches of his mean jump, which is 57. So the mean absolute deviation is 2 inches. Okay, so none of his jumps are radically different. I mean, the widest range we have here is 54 to 60. So, you know, there isn't really an outlier in this data set. If all of them are roughly within 2 inches, his jumping distance is pretty consistent. The range is the difference between the greatest value and the least value in a data set, right? So in our last data set, I said the smallest was 54, the shortest jump and the longest jump was 60, so the range is 6 inches. Right? It's 6 inches from the shortest jump to the longest jump. That's our range. That's the difference between the greatest value and the least value in a data set. The interquartile range is the difference between the upper quartile, that box and whisker plot that we did before that looks like this, and the lower quartile data set. Range and interquartile range are also measures of variability. Use the range and interquartile range to compare the data sets. All right, so the box plots show the price in dollars of a handheld game. Okay, so store A, wow, it's $24 to $150. That's quite a range. Most of them fall between 48 and 72, with the mean being 52. Okay, so find the range and interquartile range for each data set, then compare the variability, which is the differences of the prices of the handheld game players at the two stores. All right, so the first thing we're going to do is calculate the range of store A, which is this set of data. Then we're going to calculate the range of store B, which is this set of data. So let's start with store A. So our range, we went from 24 to 150. So 150 minus 24 equals 126. That's a big range there. So the range for store A is $126, right? I'm assuming it's in dollars. They don't say, but we're in America, so we're going to say dollars. All right, calculate the interquartile range, meaning right here. So 48 and 72 within our box. So 78, I can't do this, or 72, that's why I can't do it in my head. 2 minus 48 is 24. All right. Find the difference between the interquartile range, which is this. I'm sorry. The interquartile range is $24. Okay. So we have our range is 126. It's a big range. Our interquartile range is only $24. So most of the games are within a $24 range. These are kind of outliers. All right, so store A has a greater range, but store B has a greater, we don't know yet. Sorry, let's do store B. So store B goes from 30 to 120. So that would be what, 90? All right, the range for store B is $90. All right, now we're gonna do the interquartile, which is 100, and over here is 42. So that would be what, 58? So the interquartile range is 58. Okay, so now let's compare store A and store B. Store A has a much bigger range, $126 compared to $90. And here the interquartile range is relatively narrow, but here it's bigger. This is kind of a big range. This one's pretty tight right here. This one is broader, the interquartile range is. So store B has a greater interquartile range. All right, let's take a look at this. Find the range and interquartile range of the data in the box plot. So for the range, find the difference between the greatest and least. So right here is what, 19 and 7. So 19 minus 7 is 12. So the range in price is $12. For the interquartile range, we have, what's this? That's 15 is the bigger one. 14, 13, 12. So the interquartile range is $3. Heights in inches for several tomato plants. Okay, so 20 is the biggest one, 16 is the smaller one. The absolute mean deviation. All right, so they're not going to give us enough room, but we can go ahead and add all of these up, divide by 1, 2, 3, 4, 5, 6, 7, 8. So I add all of this up, divide by 8. That will give us the mean. Then, to find the absolute mean deviation, we'd have to do that column part also. Okay, so quickly. I can't do it quickly. 16, 18, 18, 20, 17, 20, 18, 17. Okay, I've got to add all of those. 6 plus 8 is 14, 22, 29, 37, and 44. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 144 divided by 8. So if I get a number that is not between 16 and 20, then I've done something wrong. So just think logically before you finish a problem. It has to be between 16 and 20, or it's not a mean. It's not, it doesn't represent this data set. I've done something wrong. Okay, so that'd be 1, 64, 18. So the answer is 18. So that makes sense. So my mean, this is now just my mean. I'm only halfway done. Okay, now I have to figure out all the differences. So 18 minus 16, I have to do 18 minus all these to get my absolute mean deviation. Then I've got 18 minus 18 is 0. 18 minus 18 is 0. 20 minus 18 is 2. 18 minus 17 is 1. 20 minus 18 is 2. 18 minus 18 is 0. 18 minus 17 is 1. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 1, 2, 3, 4, 5, 6, 7, 8. Well, they made that easy, didn't they? So 8 divided by 8 is 1. So my absolute mean deviation is 1. So first you have to find the mean. Then you have to find the difference of all the values from the mean, add them up, and take the average of those, of that data set. And that's how you find the absolute mean deviation. So you're going to do the same thing here with this one. First you're going to find the mean, like I did. Then you're going to subtract all these values from the mean, add them up, divide by the data set, which is 1, 2, 3, 4, 5, 6, 7, 8. In this case, it would be 1, 2, 3, 4, 5, 6, and that will give you your absolute mean deviation. All right, good luck.